Hello students, how are you all? I hope you all are doing amazing. So welcome all of you at AriserTalent. AriserTalent is an online learning platform where you can get a wide variety of courses you are searching for. Whether it is for NTSE, CBSE, JEE and NEET, you will get the entire content from the expert team of Kota at AriserTalent only. At AriserTalent, apart from having a very good content, you will get an idea about the previous year exam papers, solutions of your NCERT, NTSE or whatever the question you are searching from, the hardest of the solutions you will provide here. If you have any doubt regarding any particular topic, our expert faculties are always available to you. What you have to do, you have to just comment your problem in our doubt section and we will make available as far as possible and as soon as possible to this question to you. So basically at AriserTalent you will get the entire content from the expert faculties of Kota just by sitting at the corner of your room. You do not need to roam here and there and you do not need to go outside. Just by staying at home you will get the entire content of particular subject you are searching for. So this package also provides you the NCERT solutions and NTSE problems that might be very difficult to do. Previous year paper will help you to prepare yourself for the further exam also. So what you have to do, you have to just subscribe our channel, like our channel and you have to watch the videos which are freely available to you. So you become aware of the many more videos that are upcoming videos. So basically AriserTalent also provide you, it may give you the content that will be very beneficial for the upcoming exam because some exams are delayed nowadays. So for the further information or for any queries you can just go like our page, subscribe our channel and just see our videos and enjoy. So let's start today, but before that the quote of the day is learning never exhausts your mind. So whenever you are going to learn anything, it will not going to exhaust your mind. So just connect it with the AriserTalent and we will not exhaust you. So by just subscribing our channel, you will fall in love with the learning again and again. So learning will never exhaust your mind. So what we were discussing in our previous lecture, we have discussed about the magnetic effect of electric current. And in our previous lecture, we have a very good discussion about the Fleming's left hand rule. And we also discussed some of the problems that are related to the Fleming's left hand rule. Now, in our today's lecture, we are going to discuss about some of the devices due to which the electricity supply is happening. So, you can see light everywhere. This light, the fan, the AC, entire electric circuits are working on these things. So what we are going to discuss, we are going to the phenomena, we are going to stay connected with the devices that are working behind it. So in the magnetic effect of electric current, today we are going to start a very interesting topic that is about the transformer. You have heard many times about the transformer. Instead, you have seen the transformer in any electric circuit if you have seen at your home. So, transformer is basically a device which is used to raise or lower the voltage in the AC circuits. So, firstly, let's discuss about the definition of transformer. So what is transformer? Transformer is actually a device which is used to raise or lower the voltage in the AC circuits only. So it is a device which is used to raise or lower the voltage in AC circuits. So, it is a device which is used to raise or lower the voltage in the AC circuits, and it is actually run by the DC current. DC current means direct current can be applied to run any type of the devices that are associated with the electric circuit. So, transformer is actually such a device. So, it will either raise or lower the voltage in the AC circuit. Now, what actually the construction of the transformer says about it? In the construction of the transformer, you have actually a core provided. In this core, there is a number of turns of the wire. So basically, and that in that core, there is a number of the turns of the wire which is connected to the AC supply are the primary coil, and the number of turns where the output is taken is known as the secondary coil. Because in running any device, firstly you have to provide the input, that's why you will get an output here. So in the same manner, we will provide some input to the transformer, that is to the core, and we will get the output, and the output connecting the number of coils are known as the secondary coils. So let's discuss about the construction of transformer. So, in the construction of transformer, let's draw the circuit first, so it might be very clear to you. So, what will be the construction of the transformer says about it? So, in the construction of the transformer, you have seen that we have just taken a system. This is our laminated core. It means it is placed such that it can be constructed with a number of laminated cores taken. So, this will be our laminated core. So, in this transformer, you have seen that we have taken a coil here. The coil which is connected to the input source having some amount of number of turns is known as the primary coil, because input we are giving from here. And the coil which is connected to the secondary side and from where we can obtain the load is known as the secondary coil. So, it means in the primary coil we are just applying the input, and from the secondary coil we are just getting the output, and the output is always obtained at the load side. And this transformer having these laminated cores which is mounted on it. So, this is the basic structure you can consider for the transformer. Now, in the construction side we can write that it consists of number of turns wind on the coil which input supply is connected is called primary coil. It is known as primary coil, and you can see that the number of windings can be done only of the copper wire. We have heard so many times that the insulation will be done only of the copper wires. So this insulation is basically of the copper wires. Now, in other side from which output has been taken is called secondary coil. It means output we will derive from our secondary coil. So these are the two coils of the transformer we have. One is the primary one to which the input source is connected, and other will be the output side from which we have taken the output is known as the secondary coil, and the output is always taken on the load side. So this is all about the construction of the transformer we have. Now the main point is on what principle the transformer is actually working. So the transformer is actually working on the electromagnetic induction. Electromagnetic induction means when the flux linked with the coil changes, then there will be the induced EMF in the circuit. So this is the principle of the transformer we will use now, but before that just copy it from here. So next thing is about the principle of transformer. Now principle of the transformer is electromagnetic induction that we have discussed just now. Whenever there is a flow of the current in the circuit, as you have connected the input source here, whenever there is a flow of current in the circuit, the magnetic flux linked with the primary coil changes, and if there will be this flux change in the circuit, there will be a definitely induced EMF in the circuit according to the Faraday's law of electromagnetic induction. So if current is supplied, then flux linked with the primary coil changes. Flux linked with primary coil changes. And if there is a change in the flux of the circuit, then there will be the induced EMF in the circuit. It means with the change in the flux, the EMF is going to be produced in the circuit, and this is in accordance with the Faraday's law. Now, if there will be the change of flux and there will be the induction of EMF in the circuit, what will happen? If we are going to consider it a closed circuit, then the flux linked with the primary coil must be equal to the flux linked with the secondary coil. This is our primary coil. I can consider it as a primary coil because it is connected to the source side, and this is our secondary coil. This I can mention here that this is our secondary coil. So if I am considering here the flux linked with the primary coil is phi p, flux is denoted by phi, and in the secondary coil we can consider that the flux is phi s because it is of the secondary side. So if it is a closed loop, then the flux linked with the primary coil will be definitely going to be equal with the flux linked with the secondary coil. So I can write here phi p will be equal to phi s. So this is the condition we are getting from here, that flux linked in the primary coil will be equal to the flux linked in the secondary coil. Now if I am assuming that number of turns in the primary coil is Np, if I am writing here number of turns in primary coil is equal to Np, this is the number of turns of the primary coil, and if number of turns in the secondary coil equal to Ns. So these are the two things we have mentioned here, that number of turns in the primary coil is Np and number of turns in the secondary coil is Ns. If I am assuming here there is a little change in the flux, so a small change in the flux will be denoted by d phi. If there is a small change in flux, if there is small flux change in the flux, it can be denoted by d phi, because any small change we can consider here as a d phi. Now if I am going to do the small change in the primary and secondary, so what I am going to write here, I can write here d phi p upon dt will be equal to d phi s upon dt. It means there is a small change in the flux of the circuit. Then what will happen here, if there will be the small change in the flux, we will get an expression here about the induced EMF. So if I am considering here the number of turns in the primary and the secondary coil is Np and Ns, it means the primary side the number of turns are Np here, and in the secondary side we have the number of turns, that is Ns, and these number of turns are actually constant we have. So we will get here phi p upon Np is equal to phi s upon Ns. So this is the expression I am getting here. Now if we are considering a small change in the flux, considering the number of turns to be the constant, we can write here 1 upon Np will be equal to d phi p upon dt equal to 1 upon Ns and d phi s upon dt. This is the small change in the value of the flux we are getting. So what we have just done here, 1 upon Np is separated from here, and the small change in the primary coil can be written as d phi p upon dt, and small change in the secondary coil can be written as d phi s upon dt. Now can you tell me what will be the value of the flux changing with time? Yesterday we have discussed that if the flux is changing with time, we can call it as a EMF. So I can write here d phi by dt will give you the value of EMF. So I can substitute these value from here. I can substitute this value from here, and what I am getting in the expression, 1 upon Np into Ep is equal to 1 upon Ns into Es. So this is the expression I am getting from here. So it will be Ep upon Np equal to Es upon Ns. So Ep upon Np equal to Es upon Ns. So this is the expression we are getting from here, and we can also write it as, if I am going to cross multiply this expression, what I am getting here, on cross multiplying we will get EPNS equal to NPES. EPNS equal to NPES, and it came out to be NS upon NP equal to ES upon EP. So this is the expression we are getting from here, and this expression is simply, I am writing it here, NS upon NP is equal to ES upon EP. So this is the expression we are getting from here. So what we have done, we have taken the number of turns in the primary coil to be the NP and the number of turns in the secondary coil is NS. If there is a small change in the flux, that small change can be designated as d phi. Now, if the flux linkage change with the primary coil, I can write it as d phi p upon dt. If the flux is linked with the secondary coil, I can write it as d phi s upon dt. Now, d phi upon dt is nothing but it is our EMF. So, I can write here 1 upon Np into Ep equal to 1 upon Ns into Es. So, it will give you Ep upon Np equal to Es upon Ns. On cross multiplying this equation, we will get our final expression, that is Ns upon Np equal to Es upon Ep. So, this will be the number of turns and EMF relation formula which is used for solving some of the numerical problems you have. So, just copy it from here so I can write the further part of it. Now, what we will get in the final expression, we are getting here Ns upon Np equal to Es upon Ep. We are getting the expression here, Np upon Ns is equal to Ep upon Es. This is the expression we are getting from here. Now, if there will be the input current that is flowing through the primary coil is Ip and the output current we are obtaining here is Is. So, I can write here Ip is the current in primary coil and Is is the current in secondary coil. Now, if these are the values of the current, we can say that if you have an ideal transformer, you can write it as Np upon Ns equal to Ep upon Es equal to Is upon Ip. This is the condition for ideal transformer you have, and this equation shows that number of turns in P, number of turns in secondary coil, EMF in the primary coil, EMF in the secondary coil, and the current relation is just opposite to that of the Np and Ns. Here you are getting Is upon Ip. So, it will not be Ip upon Is, it will be Is upon Ip. So, you have to remember this formula for solving your numerical problems, because question will definitely going to ask from such topic and it will be only numerical based. Now, this will be the final expression we are getting here. So, number of turns in the primary coil and the number of turns in the secondary coil, if there will be the change in the flux, there will be the induced EMF, and induced EMF will going to produce the induced current. So, this is all about according to the Faraday's law of electromagnetic induction. So, we can see that transformer is actually working on this principle. Now, you can see that the number of turns and current relation we are getting here. So, here are few of the conditions on which the transformer works. So, these are the essential conditions for the transformer, and these conditions are: transformer will always work on the AC current. It will not going to work on the DC current. So, it must be a point to remember that it works on AC current. Transformer is going to work on AC, not DC. So this is a very important point. You have to remember that it always works on the AC current. Now, if the transformer is working, some of the energy is always lost in the form of the hysteresis, in the form of the heat, and in the form of the eddy currents in the circuit. So it means there will be not exact conservation of the energy, some of the energy always lost in the circuit, and some of the energy is lost in the circuit, and this will be in the form of the heat also, we have discussed here. So one more point I can conclude it from here, the energy will be lost. Energy is lost, and this energy lost in the form of heat and eddy currents. So this energy loss will be in the form of heat and eddy currents. So this is the one more important point you have to remind about it. Now, depending upon the number of turns and depending upon the current value, you have basically two types of the transformer, that is step up transformer and step down transformer. So let's discuss about both these, but just copy it from here. So now we have two types of transformer depending upon the number of turns in the coil, and these two transformers are step up and step down transformer. So the next topic is about types of transformer we have. So actually we have two types of transformer. The first transformer is step up and second one is step down. So the first one is step up and second one is step down. Now what is this step up and step down transformer? Let's discuss here. Step up transformer means number of turns in the secondary side of the coil. It means number of turns in the secondary is greater as compared to the number of turns in the primary. So we can call it as a step up transformer, and as the name indicating, step up means it will raise the voltage and it will reduce the current, and step down means it will going to lower the voltage value in the circuit. So I can write here, step up transformer is a transformer in which number of turns in secondary is greater than number of turns in the primary, and in case of step down I can write it as number of turns in secondary will be less than number of turns in the primary. It means in step up number of turns in secondary are more, and in step down number of turns in primary circuit is more. Now if its name is step up, it is definitely going to raise the voltage. It will increase voltage, and its name is step down, so it will lower the voltage. Next thing, in step up transformer, if the voltage is increasing, you can say that you will get a reduced current here. The current will be reduced, and in this case you will get a increased current. So these two transformers are just opposite to each other. So in the case of step up we are getting an increased voltage, and in case of step down we are getting a reduced voltage. So this is the basic difference between these two transformers. So I hope this topic has been clear to you that what actually the transformer is. Transformer is a device which is actually used to raise or lower the voltage, and it basically works on the principle of electromagnetic induction, in which if there is a flux change in the primary coil, then there will be the induced EMF in the circuit. So this is the whole process about transformer, and you have to remember just basic formula that NS upon NP upon NS will give you ES upon EP, but you will get IS upon IP. So this formula is very important for solving your numerical problems. So this lecture is over here. We will deal with many more lectures in our next section. Thank you so much and have a nice day.